All right, everybody. So in this next video, similar to the last one, only I'm not going to go into the specifics such as this right here. I'm going to go through it quickly, but if you have specific questions, please come talk to me in class, right? So I'm just going to give you an overview of this pathway, mostly because pictures help. Take all this information, and I want to look at it from the picture, right? So if we're looking at this picture, one of the big things here is, and one of the major differences here is that the hormone, which is up here in the upper right hand corner, it is not going to pass through the cell membrane and go to the nucleus. So when it comes to non-steroid hormones, which again is the whole part of this video, is they cannot pass through the cell membrane. Okay? What they need to do instead is they need to bind to a receptor, such as right here. When they bind to this receptor, a cascade of effects is going to happen. So, in other words, a domino effect is going to occur. It binds to the receptor, which is going to cause something to happen here, which causes something to happen here, which causes something to happen here, which eventually will result in the goal, some sort of cellular change. Now, clearly, I just skipped over all these words. What I want you to understand before we even look at any of these words is just the idea that when a hormone, non-steroid hormone, binds to its receptor, it is going to trigger a cascading effect, which is going to cause certain enzymes or substances within the cell, like we did 2 seconds ago, to change, which then cause something else to change, which cause something else to change, and this can continue on for quite some time until eventually you get your goal, which is a cellular change. Okay? So in other words, it's just step-by-step domino effect. Okay? Now, if we want to see specifically what's changing, that'll be this part of the video we're moving into now. So we're going to go back in time. I just wanted to show you that first. I thought that was important. Let's use some of the terms now. So, endocrine glands are going to release the non-steroid hormone, just like we talked about. The body fluid is going to carry that hormone to its target cell, and from there, it is going to bind with a receptor on the cell membrane. Okay, so this is just like in the picture, just like what we saw right here. It's going to bind to the receptor. Wow, that is frustrating. I'm so sorry. It's going to bind right here to a receptor. Okay, so that was the first part. Now we're going to go back in time again because this thing doesn't like me. Here we go. Let me clear this off. Now, what happens next? Specifically, this is going to activate something called a G protein. Once the G protein is activated, we're going to start to see a continuation of activating other enzymes and molecules. Adenylate cyclase is the main one here. It is going to be used because it's going to be activated. So once a G protein is binded to, this adenylate cyclase is then going to become activated. Once you activate that, then we can convert ATP to cyclic AMP. All right. I'm going to try to use an example to help see if this makes any sense, a little bit more sense. So right now we're hearing, okay, so the hormone is going to bind to its receptor, and then once it binds to the receptor, G protein's activated. Okay, and then when G protein gets activated, adenylate cyclase gets. What does that even mean? So imagine, let's say we want to make some bread. Okay, so if we want to make bread, we need to include water. We need to include yeast. We need to activate the yeast's ability to start to ferment the bread. Right. So in other words, you can have a whole bunch of flour sitting there on a table, but that flour isn't bread. Right. You need to make dough first. So in this case, adenylate cyclase would be kind of like putting water into the yeast and into the dough. Once it's activated, that dough will start to rise. So again, that flour will start to rise into a dough. So in other words, before you even bind, you just got flour and water and everything separated. Once it binds, the uh, adenylate cyclase is going to activate it, and just like putting water into your dough or to create the dough, it is then going to start to activate, and the yeast is going to start to eat, and it's going to be able to start to rise the bread, and that process can begin. So in other words, you can't make bread or pizza or anything else until that first step. This is step number one. It is vital. From there, you can create the dough. Then once you create the dough, just like over here, cyclic AMP can then activate protein kinases. So if you want to make bread, you can't make bread unless you have dough. Then you could take that dough and put it in the oven. So in other words, one more time, I'll do this in purple. You start here at the beginning, step one. Again, it's kind of like cooking. You cannot eat bread until you bake it, but you cannot bake it until you make dough. And you can't make dough until you put the water with the other ingredients. So step one, step two, step three, and then at the end, you have your protein that your cell is going to produce. So in this case, it could be a number of things. What is your hormone telling your cell to do? Is it telling it to create something? Like I just said with bread, right? So in that example, is it telling it to stop making something? Right? So it depends what the cellular response is. But again, long story short, there are many steps to getting that desired effect. All right. So again, if you have any questions with this, let me know. They're a little bit challenging pathways to start the class. But like I said, let's talk if you have any questions.